Hello there, trust you're doing well. Now, earlier this week, I had the privilege of attending and speaking at the 15th KEMRI Scientific and Health Conference, and I was talking about how we can leverage technology to advance RMA efficiency. And across other fora that was speaking about technology, I could feel the major pain point in science and research currently, not only in Kenya but Africa, is the aspect of collaboration. And when you talk of collaboration, it's data based. We collaborate on the data you have generated, the papers you have written, uh, specific, explicit knowledge that you have unearthed in science for the benefit of other studies. And I talked about data sharing and its management. So most of the time you find out when researchers carry out a study and it culminates to an output such as a research paper, there was data that was involved, especially where there was data collection in the field. Now, how do you manage these data sets that culminate to statistical analysis and they are further referenced in papers? Then comes in the principles of data sharing, specifically fair data sharing. So, a fair in its purest sense is spelled fair, indeed fair, FAIR. It's an acronym that carries four principles of data sharing and management to ensure that data is number one, findable, number two, it's accessible, it's interoperable, and finally, it's reusable. And it is easier said than done. For you to ensure that this data is fair and conforms to the principles that I've just mentioned, fair, then you have to look at what kind of mechanisms can you employ with regards to technology to achieve this. And as I was doing my research, I came across um, a few a few areas where fair data sharing could be employed. And number one could be the epidemiological data sharing. Number two could be genomics and biomedical research. And number three is government and open source data initiatives. Now, having said that, I have to say that we need to also look at the systems that could help us achieve fair data sharing and management. And in no particular order of simplicity or complexity, there are four systems that I identified could be easily deployed in a research scenario. And our goal, do not forget, is to ensure that this data conforms to the fair principles of findability, of accessibility, of interoperability, and reusability. So let us look at, for you to say that data conforms to those four principles. Just before we go to the technology, to the software bit of it, which I'm anchoring towards, let's look at, let's have a deeper look at the FAIR principles. So when you say data is findable, what do you mean? That data should be easy to locate and it should be easy to locate using metadata and identifiers such as DOIs or digital objects identifiers. So that is one. And when we say that data is accessible, what do we mean? Essentially, the data should be retrievable via open, standardized protocols with appropriate authentication and authorization where needed. So remember, the to say that data is open, it does not necessarily mean that there's no authentication, that it is free and open. No. Sometimes data will be open, but yet it requires you to be registered to have an account in a particular portal to access it. It's not, let's say, free for all, right? Then the other thing is interoperable. So this is basically to mean that data should be in standardized formats to allow integration to other systems and integration into other data sets. So when you say it's interoperable, it's, for example, meaning that to access your data or to share it, it uses, for example, mechanisms such as REST APIs to be accessible. You could say it is also shared via mechanisms such as, or data types such as XML. So your data it's in an XML format. It's on a JSON format, which is standardized. So if anyone can make a GET request on your system, and they can retrieve the data that they require, given the set of conditions that you have set. Your data could also be retrieved, can be downloaded using formats such as Excel, CSVs, tab separated values, such kind of things. So it should be in a standardized format. The other thing is reusability, that this data should be well documented such that if I, as a researcher, wanted to cite it, it's easy for me to cite your data, and it should have very clear and simple licensing terms. So you've said for you to use this data, this is the license, these are the conditions, you use it, but you reference us, or and whatever conditions. Your data should not be vague. Someone should not access your data and then the next moment they are being sued. It should be very well documented. It should have very clear licensing to support reuse and reproducibility. So that is what we mean by fair principles of data sharing and management. Now let's go to the technology bit, which I am very passionate about because I'm a computer scientist. I am also a developer. I write software. I'm majorly involved in automation of processes. Now, we are talking about collaboration, and one of the tenets of collaboration is data sharing and management. So, which kind of tools can we use to ensure that we are able to share data conforming with the fair principles of data sharing? So number one, we have Dataverse. The Dataverse is an open source, and I have to say that I am quite inclined to talk about open source software because of the great potential they have in being extended and supported by so many people. It is not a cabal of developers and corporates who sit somewhere and decide this is the direction we want to go. Open source, as much as it has anchor community members, it is supported by a whole host of community individuals and a whole community behind it of developers, implementers, and architects. So most of the technologies I tend to speak about are open source. So let's get back to it. So number one, we said we have Dataverse. Dataverse is an open source repository for sharing, managing, preserving research data. And it is FAIR compliant. It uses persistent identifiers such as DOIs, the digital object identifiers, and I hope I'll get to show you. I have had an opportunity to install it locally on my machine, and I plan on pitching it to the research institute that I work for to see whether we can embrace it and to host our datasets. It supports rich metadata. Metadata is another key element of data sharing, because if you have data sets yet you do not have descriptive data about that data set, then it becomes a little bit difficult to conform to the findability of that data. So it uses persistent identifiers such as DOIs or digital object identifiers. It uses rich metadata, which we shall see. Then it also has a standardized way of access, as we will show. And this is APIs. There's a standardized way of consuming the data in Dataverse. Um, then the other thing we could just mention, institutions, notable institutions that are using Dataverse are the Harvard Dataverse chapter. We have the European Open Science Cloud. And for me, to be honest, I have looked at the repository, I've looked at the code, and I feel it's a really formidable platform or technology to use in terms of management of metadata to ensure that institutions, institutions in probably the same geographical region in East Africa or even in Africa, we are able to share data in a standardized format and in a well managed manner. Because as much as we rely on donors for the huge chunk of our research, it does not mean that our data needs to rest with those people who are commissioning research. We need also to consume data in our local context to be able to come up with solutions in our local domains. So that said, let me go to the next tool, which is Fair Data Point or FDP. It's described as a lightweight open source framework that enables fair data publishing. To be honest, I haven't used it, I haven't installed it, I haven't examined it, but as I was doing my research, I decided to go to the documentation and just see what's happening with them. So the FTP team claims that it uses machine readable metadata. I mean, of course, all the systems have machine readable metadata that supports digital objects, fair digital objects. It is used by institutions such as GoFair and Dutch Health data initiatives. There's a website that I will leave there for those of you who want to go and look at FDP. Now, the other system is SICAN, or the Comprehensive Knowledge Archive Network. This one is Python based, and I have actually run it on Docker on my machine locally. And I can say I liked it, but as much as it's an open source data management system for publishing open data, it requires you to do a little bit of configuration for third parties for basic data publishing and review. You see, for Dataverse, if I have a CSV file and I want to just upload it, do the metadata, and then preview the data, I don't have to install anything else. But for SICAN, you have to install off the cuff. You have to install a little bit of extensions, plugins for it to work the way you need. I found it um, a bit exhausting when it comes to minimal working with it, but it's nonetheless it's a good tool. I do not think the UI is modern. It's a little bit it's a little bit lagging, but it's a good tool. I've installed it, I've used it, but I found it a little bit difficult as compared to Dataverse. Then, and by the way, SICAN is also used notably by government open data portals for the UK, for Canada, for the EU. I will also leave a website for that. And then we also have, finally, Arrow Crates. Arrow Crate, that is the research object crate. I wouldn't call it a platform. I would essentially call it a framework for packaging research data. And in fact, the Arrow Crate format is also supported in Dataverse. Uh, Essentially, it's a framework for packaging research data with structured metadata for fair compliance. So finally, I forgot to mention um, we have two other systems, and one I've seen used in 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 repositories for libraries, and that is DSpace. It's an open source digital repository system widely used in academic contexts and research institutions. So, for those people who are running their academia, where students publish papers or release papers, and people who are running libraries digitally, this space is a great tool. But I wouldn't really say I would trust it with full fair compliance for research data sharing. It's uh, more of academia and a library setup. It will work well there. Then we have open air. Open air is described as a European open science infrastructure that supports fair data management. It implements fair metadata standards and APIs. APIs are for the interoperability bit and accessibility bit. Um, so yeah, and it is used by European Open Science Cloud, EOSC, and I'll also leave a website to that. So just to sum up, we said that we have five systems that you could potentially look at if you're looking at trying to improve collaboration in science in the area of data, specifically management of scientific metadata. So we said we have Dataverse, then we said we have FDP or the Fair Data Point, then we have SICAN or the Comprehensive Knowledge Archive Network, then we have Arrow Crate, and we said Arrow Crate, not necessarily a system in my opinion. The major contribution is to a framework for packaging, research, data, and to structure metadata for fair compliance. So it's a framework per se. And then we have OpenAIRE, used by the European Open Science Cloud as an infrastructure. Then we have DSpace, which is an open source repository system widely used in academic and research institutions. Um, yeah, so that is the technology bit of managing scientific metadata. And we spoke about the principles that we should adhere to. We should adhere to for the sake of compliance and allowing us to share data in a standardized manner. So, and I would want to speak to the notion of identifiers. So let's say you have people working on tuberculosis, you have people working on malaria, you have people working on cancer, and all these studies are creating data sets, so to speak. Because remember, it is a data set that we use to do further analytical work. So if you do not have a data set, there's no way you're going to draw insights from your data. So you collect your data, you package it well. It could be even an Excel that you use. It could be a MySQL database that you, for example, if you've used an open source tool to collect your data, it has forms with various fields, which sends data to a MySQL database or T-SQL or Microsoft SQL Server. That forms your data set. Your data set will be a series of tables. So if you're using Excel, a form that stores data in Excel, that Excel, the final file that stores your data will be the basis of your data set. That is what you will use to analyze your data with whichever tool that you like. So we are talking of how do we manage these data sets that are the foundational blocks for our analytical work. So that is the entire conversation that I am trying to have with you. And for us to manage this data, we could have tags, we we have the issue of licensing, we have the issue of how do we make this data easily findable. Whenever you're looking for a particular resource or information on Google, we used to speak, and we're still talking of search engine optimization. I mean, how do you ensure your data ranks highly, is easily findable? Now, in the context of our research data, it needs to have certain characteristics and certain metadata attributes to assist us find it easily uh, for reusability. So when we store data, we need others to be able to use it. We need others to be able to reference it and cite it or ask for more comprehensive uh, data points about it. Because not everything you put online, you could probably put some teaser, and if you want to commercialize again other bits of data just to recover your cost or anything, then you could say if you require more data, then contact this researcher, and then you can come to an agreement on the basis of how they're going to share that data with you. Because data is the, so to speak, is the new gold standard. Yeah. So let's speak about a unique identifier for data in the realm of um, data sets, scientific data sets, and that is the digital object identifiers. So DOIs, a DOI is a persistent, unique identifier assigned to a digital object, such as a research paper, such as a data set, as you're speaking, such as a report, a software, ensuring that it remains findable and accessible all the time. It's a unique identifier, which is a digital identifier, digital object identifier. So the object in this particular case, we said it could be a report, it could be a data set, it could be a paper, right? So papers will actually have journals. It is it is well known that when you publish a paper, when you do a paper, the best place to place it would be on a journal, on a publicly accessible journal. Here we are talking about the data set, what you used when you went and collected that data in the field, where did you store your data? Hmm? So maybe you are working with RStudio and for some reason you have collected all your data and you have imported it into RStudio and you only want to share an RStudio file or a starter file. So you need a system that could host that, could offer people a way to preview that data and to uh, read more about it and probably ask questions about it and reference it, right? So there are features of, so we said you use a DOI. DOI, essentially it's like a URL, only that it's persistent. It should not break. It has particular properties. And so let's look at them. Number one is persistence. Um, DOIs do not break or change, even if the content is moved uh, to a different location. The DOI should not break. That is one of the properties. The other thing is uniqueness. Like URLs, they should be unique. They are globally unique and they should actually prevent duplication or ambiguity. The other thing is that they are machine readable. DOIs work with metadata that can easily be integrated into FAIR compliant systems such as those we just talked about. And finally is their resolvability. They are resolvable. Anyone who deals with URLs, you want to type it or paste it on the URL bar and it should resolve to a page. So similarly, DOIs link to a landing page or a repository where the object can be accessed. And I will show you when I'm doing a demo. Hopefully, I will do a demo of Dataverse. I really liked it. It has been done. A huge chunk of it is done in Java. There are other bits. There's the front end. There's the back end. There's um, a search. It uses an Apache Sol. There's a search engine for that leverages the metadata that we are talking about. And I hope I will also get an opportunity to just clearly show you what we we mean when we talk about dataverse collections and datasets. And essentially, a dataset could be a file. It is a container for your data or your code and the metadata. But a dataverse collection is a container for your datasets. So you have a container, in it you have your particular datasets. But for a dataset, it is a container for your data, right? So as we are looking at Dataverse later, I hope I'll get an opportunity to talk further about how the datasets are managed and archived and shared, and the features of uh, FAIR principles, how they are complied with in Dataverse. So with that, ladies and gentlemen, I just wanted to give you a sneak peek of um, uh, one of the one of the pain points when it comes to research collaboration, and that is sharing of metadata and its management. So thank you for your time. My name is Francis Mwangi. Till next time, cheers.